Hello and welcome to another edition of Cracking the Cryptic, where we're going to look at Sudoku today. I've just opened up the Deadly Killer Sudoku from Saturday's edition of the Times. Right, so without further ado, what I'll do is I'm just going to pause the video quickly while I fill in things like, this can only be 1-3, so I won't do anything clever, but it just saves time. Okay, so there you can see I've just populated the grid with, given numbers, I guess. 30 in 4 cells can only be 6, 7, 8, 9, so that's why I've filled in this box like that. And the most obvious initial point would be this one. We can actually write in the value of this cell, and we can do that because we know that the first two columns of the grid must sum to 90, because they'll contain the numbers 1 to 9 in each column exactly once each. 1 to 9 sums to 45. So let's, if we look at the boxes entirely contained within the first two columns, we have 4 plus 9 is 13, plus 22 is 35, plus 20 is 55, plus 12 is 67, and plus 20 is 87. So we know that this must be a 3 in order to ensure that the first two columns sum to 90. And that 3 is a little bit helpful because it resolves this 4 at the top here, this box 4 at the top. And with the harder puzzles, you should always try and use the numbers that you get as much as possible. So I'm immediately just using simple Sudoku logic here, and I'm thinking I need to place a 3 in one of these 3 cells, and you can see it can only go here. And that also allows me to place the 9 in this box here, so let's just run that through like that. Now, and again, I'm going to use my own advice here. So we have a 9 here, and you can see in this 24 box there needs to be a 9. We don't know where the 9 will be, but we do know it will be in one of these 3 positions. Now that means I need to place a 9 in one of these 3 cells here. Now, it can't go here, that's the first thing I'd note, because if it goes here we'd have a 3 beneath it, so that's not possible. Now, it could go here, I can't see a reason why it couldn't, or it could obviously go in this cell. So we've limited the 9 into one of these 2 positions in this 3x3 box. Now let's just take a look at the grid. Okay, so there's a variety of bits of geometry that similar to what we've done in the columns 1 and 2 here, that we need to, I think, pay attention to in the grid. Let's start down here. This box has to sum to 45. Now we've already got 20 plus 12 is 32, plus 3 is 35. So we know these 2 cells here are going to sum up to 10 in order to ensure the box works. And because this cell is limited, actually eliminate those 2 possibilities there. This is going to be an 8 or a 9 now. Now where else can we look for some guidance? Well, bizarrely enough, if we look at rows 3 and 4 here, we can see that we have a lot of cages entirely contained within columns 3 and 4. The exception being this 19 box, which sort of sticks out down here into row 5. I can't remember if I said rows 3 and 4 or columns 3 and 4, but I'm looking at rows 3 and 4 here. So if we sum 22 plus 14 is 36, plus 21 is 57, 72, 83. We know these 2 cells here are going to sum to 7, and therefore these 2 are going to sum to 12. That's a bit unlucky actually, because that's not going to help us greatly. We can see if we have 12 here plus the 16 here, that's 28. Therefore these 4 cells are going to sum to 17. But we can't use that, I think, to make any definitive progress yet. But let's do the same trick again over on the right hand side of the grid. Let's look at columns 8 and 9, where we've got 3 cells sticking out in columns 8 and 9. These 3 here that I'm sort of highlighting. So let's just check the values here and see whether that can help us. 14 plus 11 is 25, plus 19 is 44, plus 20 is 64, plus 6 is 70. So we know that these 4 cells here are going to sum to 20. Oops, I need to put an 8 in there. And therefore, because we've got a 24 and a 19 box here, we know that these 3 cells are going to sum to 23. Now, it's not quite as straightforward as if you had a 23 cage in the same 3x3 box, which we would then know would be 6, 8, 9. But it's still a very high total for just 3 cells. So, you know, if this was a 7, for example, that's one of the options that it could be, this would have to be 7, 9. It would have to be 7, 9 in this order. Now, if this was 8, then we'd need these two to be 15. This could be 7, 8, or 6, 9. Oops. And if this was 9, we'd need these to be 14, which is less helpful. We're going to have a 5 and a 9, or a 6 and an 8. So, but this can't be a 6 here. Yes, it can, because it could be this way around in that situation. So we've sort of limited a bit this box, but maybe not enough. But we can maybe think about it further. If this is a 7, we know these two have to add to 16, and therefore these two would have to be a 1 and a 2 in that situation. 15 would be 1 and a 3, and 14 would be, these two would have to sum to 5. So again, nearly, but not quite. And the next thing we should do, though, is to continue using this sort of, the fact that we've worked out that this cell, and this cell sum to 23. Because you can see now in columns 6 and 7, we're able to isolate the value of these 2 cells now, because we've got this 23 here, plus 15 is 38, plus 12 is 50, 54, 62, 74. So we know these 2 cells now have to sum to 16 in order to ensure that columns 6 and 7 add up to 90. Now, if this is 16, this has to be 7. And that is also interesting, because now look at the central column of the grid. We've got 3 cages, in effect, that contain the value 7. Now, there are only 3 ways of making 7 in a 2 cage. That's 1, 6, 2, 5, and 3, 4. So we now know that these 3 cages here contain exactly those numbers in some order. Now, that means the other 3 cells in the column have to take the 7, 8, and 9. So we can fill those in like this. And we can use the fact that we have a 9 in here to conclude that this 14 can't be a 5, 9, it's got to be a 6, 8. If that's the case, this can't be a 6 or an 8 here. And we're still left with having to place 2, 4, 5 in these cells here. So 2, 4, 5. We know this adds to 7, so this is 2, 5, 3, or 2, 3, 5 is the only options there. And we can go back to some of the logic we looked at earlier. Remembering again, we've got these 3 cells isolated in value to 23, and we said if this was a 7 here, these 2 would have to be summed to 16. So if this was a 7, this would have to be a 9. Well, now that's not possible, because if we have a 9 here and a 7 here, this cell cannot be filled. So we can actually say this cannot be a 7 anymore. And similarly, if we do the same I'll ask ourselves the same question, but ask ourselves if this could be a 9. If this is a 9, again this will be a 7, and this will be a 9. Well, we now, if this is a 9, we know these two cells have to sum to 14. Now we know the 6, 8 possibility isn't possible because this can take neither a 6 or an 8. So this would have to be 5 and 9 in that instance. But if this is a 5, this would be a 9, and this was already a 9. So again, this cannot be a 9 either. So we're able now to conclude this is an 8. And as this is an 8, these two cells have to sum to 15. Which means we definitely can't have a 5 in here. We're either going to have a 7 and an 8, or we're going to have a 9 and a 6. And that's quite nice now, because in this top box now we've got 6, 7, 8 and 9 all taken here. We know that 5 will be down here, but we don't know in which box it will appear. And we've still got to place 2, 4, 5 and 6 in column 7. In this box, well, it can't take a 2 and it can't take a 6, so this has to be a 4 or a 5, and this has to be a 7 or an 8 now. And if we remember correctly, we said we've isolated these two to be 15, so these two have to add up to 4. So in fact we're looking at 1 and a 3 in these two positions. And that's lovely now, because we have a 3 and a 1 here, and a 3 and a 1 over here. So these two cells have to be 1 and 3, because this obviously is a 7, 8 or a 9 we've managed to work out already. So put the 1, 3 in, put the 1, 3 in here like this. And now we know that this is 2, 4, 5 in some order. So we're left with 6, 7, 8 and 9 to fill these cells here. Now, the fact that they've got a 1 and a 3 here means we can't have a 3 here and we can't have a 4 here. So in fact the 7 that we knew these were has to be 2, 5 now, which means this can be neither 2 or 5, and this has to take a 4. Let's remove 4 from here. And I filled in the only possibilities this can be here, because we've already got 1, 2, 3, 4, 5 taken. We knew this was a 6, 7, 8 or 9. Well, it can't be a 9 because of this, so it's 6, 7 or 8. And if we look down the column here, we've now got a triple on 6, 7 and 8s in the column. So we know the 6, 7, 8s in column 4 are in these 3 cells in some order. So we're now left, we're able to conclude, I guess, that the other cells can only take 1, 2, 3 and 5. And I think that's going to be very useful, because it just feels to me like this 21 box now is getting very restricted. Not quite restricted enough though. But we can use some more Sudoku logic here. So we've got a 4 in one of these 3 positions, and we have a 4 here. So we know that there is a 4 in one of these 3 cells. Well, the 4 can't go here, because that would mean that this 21 cage contained 2 4s. So this actually means that this 9 has to be 4, 5 in some order, which allows us to conclude that that must be the way that this box here works. Okay, which means this is a 2. So now these two have to sum to 15. It's going to have to be the opposite way to these two, whatever these two turn out to be. If this is, 6, 9, this will have to be the 7, 8 variation. So it means we've got, what have we got now? We've got 7, 8 or 9 here in this position. Yeah, that looks correct, I think. And again, I think we can make more progress now by looking at the limited possibilities for where to place 1s in this box. Because we have a 22 box here poking down. Well, obviously that can't contain a 1. This 1 here means we can't have a 1 in any of these 3 positions. We can't have a 1 here because that would make this box 10. So the question is, could we have a 1 here? And the answer is no, because if we have a 1 here, these 2 cells have to sum to 15, and given the options we've identified, that's not going to work either. So that means that the 1 is in one of these 2 positions in this 3x3 box. Let's write that in and see what it tells us. Well, that means the 1 down here is forced over into column 3, and there's only one position that can go, and that's here. Now that's quite useful because that will allow us to rule out a couple of possibilities further up the grid. And something I like to do in situations like this, if I was looking at column 3, I'd be going, okay, I've limited the value of 6 of the cells, but I'd be thinking, okay, what numbers do I need? I've still got to place a 4 and a 5, yeah, and I can instantly see that it's not possible that this 14 contains both of those numbers. Now, if that's the case, if this 14 doesn't contain both of these numbers, then this must be a 4 or a 5. And that's reasonably helpful, because this 4 means, if this was 4, this means these 2 have to add to 12. I'm going to eliminate, so 1 wouldn't be possible. If this was a 5, this can't be a 1. So I can remove the 1 as a possibility immediately as a result of working out this has to be a 4 or a 5. Now that shifts the 1 in column 4 up into this 20 box. I don't know in which position yet, but we know now it's going to contain a 1. Can't quite conclude there's no 7 here, but we're definitely closing in on completing this puzzle in the near future, I think. Because again, we can use the same logic. The fact that there isn't a 4 and a 5 in these 2 positions means that there must be exactly one 4 or 5 in one of these 2 positions. So that means that the options here, you can say which order it is, but it's going to be 7 and 6, 7 there. And you can see here that actually it's more limited than that, because the 4 and 5 cannot go into this cell. Therefore the 4 and 5 must in fact be in this position here. So all of that logic allowed us to conclude that the 4-5 pairing in column 3 actually sits within this 3x3 box like this. We can go back and use some of the logic we worked out earlier, that these 2 cells here had to sum to 7. That was one of the first deductions we made. Well, you can see now if this is a 4, this would be a 3, and that's ruled out by this 3 here. So this can't be a 4. This has to be a 2 or a 5. Now, is that helpful? Or more helpful, I should say. Well, we know these 2 cells have to sum to 12, and now they can't be 5, 7. So this is looking at being 4, 8 or 3, 9. And I don't think we can tell quite which one of those is correct at this stage. Let's fill in the options for this just while we're here. 6, 7. But we can rule out one of those options at least, because if we look at column 7, we've still got to put a 6 in here somewhere, and we know it's going to be in one of these two positions. We don't know which one it'll be yet, but we know it'll be here or here, so there definitely can't be a 6 here. There definitely can't be a 5. And 7, 9 is useful, obviously, because we've seen it appearing in so many cells in the grid. You can now see we've got a 7 and a 9 in these two positions here, so this can't take a 9. This can't be a 3. I've just spotted something now. I was reminding myself that we know that the 9 in this 30 box has been forced over into column 3 in one of these two positions. So this can't be a 9 here. Now if this can't be a 9 here, we know these two cells have to sum to 15. This can't be a 6. So this is 7 and 8. And therefore this is 6 and 9. And that ought to be helpful, because we can fill in a lot of stuff from that. The fact that this can't be a 9 now, we still need to place a 9 in this. So the 9 is in one of these two positions here. And we can do a little bit of maths here, I think, to conclude what sort of 22 box this is. So let's ask ourselves the question, if this is an 8 here, this is going to be a 7, this is going to be an 8, and therefore this box here could not be a 5, 8, 9 box. So if this is an 8 here, this cannot be a 5, 8, 9 box. There's just no way it would work. This would have to be a 6, 7, 9 box, which would, I think, be possible. If, on the other hand, this is a 7, this is a 7, this is a 6, this is an 8, and this is a 7. So we've now got a 7 and a 6 in this row. So this would have to be a 5, 8, 9 box. Yeah? But there's already two 5s in this box here, so the 5 would have to be here. Now that's not possible, because if there's a 5 here and a 5 here, there has to be a 5 in one of these 3 cells by Sudoku rules, and there isn't. So in fact, this cannot be a 7. This has to be an 8. This has to be a 7. This has to be an 8. And we are looking here at a 6, 7, 9 variation. With a 9 in these two positions, one of these two positions. So this is a 6 and a 7 as well. And that is very helpful. That gives us this 9 here. Oops. It's going to be an 8 either. We can remove 8 from these two positions. And therefore we can remove 7 from this position. It's been a good puzzle today. It's taken a bit of thought. So now this 20 box is forced. We're now looking. We now know this is a 1, 2, 8, 9. 2, 8, 9, 2, 8, 9, 2, 8, 9, 2, 8, 9. And then we can use the fact we have another of these 7, 9 pairings in row 4 here to say that this must be a 6, which means this must be a 6, which means this is a 5, which helps in a few places. I think that's going to be the final hard deduction, if you like, from the puzzle. Okay, so we now can eliminate 5 here. That means this is a 5. Which means this has to be a 4, this has to be a 7, this has to be a 9. This is 4, 8 in some order. And this cannot take a 7, so the 7 must be here. Simple Sudoku logic, we can place the 5 into this position, which forces this to be a 5 and this to be a 7. This 8 box now has to be 3, 5 in some order, which means that the 7 box here must be 1, 6, which means it must be this way. This still has to be 3, 4, which would have to be this way round. This would have to be an 8, this would have to be a 6. And I should write in the options for 8 like that. And then lots of these things are ruled out now. We can't have any 4s over here. Now these had to add to 12, I think, so if we can't have any 4s, this has to be 9 and 3. 3 and 1, 9 and 7. What are we left with placing? This can't be a 4. So in fact this has to be a 6, I think. So this is a 6. That means this cannot take an 8. This must be an 8. This must be a 4. This must be a 4. This must be a 2. This must be a 6. This must be a 1. This must be a 3. And there we go. I mean, the puzzle is, of course, solved now. It's just a case of tidying it up. Do like this. 5, 4, 4, 7, 8. Six, 8 into these two positions, which has to be this way round. This has to be a 2. And that's it. So a very good puzzle today. A few techniques shown. Hope it's useful for everybody, and see you again next time on Cracking the Cryptic.